Hi guys, I'm Emily and I've been researching polymers in everyday cosmetic and personal health products. Firstly, what is a polymer? A polymer is a long chain made up from repeating units known as monomers that are joined by covalent bonds. Generally, there are two types of polymers, natural and synthetic. We'll be looking at synthetic polymers that are formed mainly by two methods, chain growth and step growth polymerization. Chain growth polymerization is commonly also known as addition polymerization. It is commonly performed by unsaturated monomers, typically alkenes which contain a double bond. The example I'll be using to talk you through the three steps of chain growth polymerization is ethene. Put simply, an addition reaction takes place between monomers where they combine to form a polymer without loss of any molecules. Monomers that have a closed ring can also undergo chain growth polymerization, examples of which you'll see later in the video. There are three stages to any addition polymerization. Initiation. This is where a reactive initiator molecule attacks a monomer to form a reactive end group, meaning that it is able to go on and form its polymer chain. In the polymerization of ethene, the initiator is a peroxide, which when heated forms free radicals, a species with an unpaired electron, which go on to attack the ethene monomers to form that reactive end group. In the example of ethene, the bond breaks homolytically, meaning if the two electrons released from the covalent bond, one moves in each direction. Propagation. The reactive end group reacts with other non-reactive monomers to form a polymer chain where the reactive end group is effectively transferred along the polymer chain to the end of the newly added monomer. Termination is the final step in which the reactive end group is deactivated, ending polymerization. This is important as without this step, the polymer would carry on growing and growing. In the example of ethene that I have used here, there are two possible ways that termination can take place: chain combination or disproportionation. The addition polymerization of ethene to polyethene is an example of free radical polymerization. This means that the reactive end group that's formed on the monomer is a radical, meaning it possesses an unpaired electron. The types of chain growth polymerization are named according to the nature of the reactive end group. For example, radical, or there is cationic, presence of a positive charge, or anionic, presence of a negative charge. In each case, the initiator that is used is dependent on the type of addition polymerization. The same goes for the mechanism of termination in order to deactivate the end group. The other main type of polymerization is step growth polymerization. Now, there are no three separate steps to this. The same mechanism occurs throughout polymerization. No initiator is needed for this process either. Step growth polymerization is dependent on condensation reactions between monomers. So generally, a small molecule, like water, is lost during this polymerization. A common example of a step growth polymer is nylon 6,6, which is used in clothing. A condensation reaction takes place between a 6-carbon diacid and a 6-carbon diamine. Here you can see as the two monomers join, water is lost. Now, you may have been aware of common everyday polymers, such as polyethylene in plastic bags and nylon in clothing. But did you know, if you're currently wearing hairspray, mascara, or I'd like to hope deodorant, you're in a lot closer contact with polymers than you might have realised. In this video, I'll be focusing on two particular polymers in detail and looking into their properties and purpose in the product, their synthesis and any controversies surrounding each particular polymer. The first polymer I looked into is PPG-14-butyl ether, also known as polypropylene glycol butyl ether. Bit of a mouthful, so you can see why the abbreviation is necessary. The monomer or repeat unit that makes up this polymer is propylene glycol, shown here. This means that the polymer chain is a polyether, so each monomer is connected by a carbon-oxygen covalent bond. The number 14 in the name represents the 14 propylene glycol units in the polymer structure, and the butyl part of the name represents a 4-carbon chain on the end of the polymer. In cosmetic and personal care products, this polymer is typically used in deodorants and skincare products, where it enhances the appearance of dry or damaged skin by reducing flaking and restoring suppleness. It is also used in hair dyes thanks to its ability to enhance the appearance and feel of hair by increasing suppleness, volume and sheen. It can also improve the texture of hair that has been damaged physically or chemically. PPG-14-butyl ether is an example of a chain growth polymer formed through anionic addition polymerization. Although the repeat unit of the polymer is propylene glycol, the polymer is formed by the ring-opening polymerization of propylene oxide. In the case of PPG-14-butyl ether, butan 1-ol is the initiator, with a base, usually potassium hydroxide, acting as a catalyst. When I was researching this particular polymer, the controversy that struck me was the moral issue of animal testing. This is a highly campaigned against issue, and in a report I found, there was mention of pregnant rats, mice, and even dogs being used for the testing of PPG butyl ethers. Although deemed safe as a cosmetic ingredient, the report stated seizures in mice and a seizure in dogs, and potential skin irritation was also observed. The next polymer I investigated is found in hairspray, and it's called PEG12 dimethicone. It is made up of two individual polymers, polyethylene glycol and dimethicone, a silicon-based polymer. Here you can see both the monomers that make up these individual polymers. Now, this polymer has a similar name to the polymer beforehand, once again meaning there are 12 repeat units of ethylene glycol in the polymer chain, and there is on average around 4 to 20 repeat units of dimethicone. This particular polymer is a cross polymer in which two individual polymer chains are cross-linked. In the case of this polymer, they are linked by an alkyl chain that can cross-link the different polymer chains together covalently. But why do this? The cross-linking of polymers has the ability to modify its overall properties. In the case of PEG12 dimethicone, the addition of the dimethicone polymer to the polyethylene glycol polymer gives formulas a smoother feel, promoting spreadability and adds lubrication. This polymer is reported to be found in 28 leave-on products, 17 of these being deodorants, and 3 rinse-off products. Its use in the cosmetic industry is most commonly in hairsprays, shaving soaps, and shampoos. This is thanks to its effectiveness as a hair conditioning agent and its ability to act as a wetting agent. This means when added to a liquid, it reduces the surface tension, resulting in the formula being more effective at spreading over and soaking into a surface, a common feature in hair products. The polymer also acts as a foam builder, essential to help the shampoo lather up in your hair. Aside from hair products, it's also found in skincare, lotions and perfumes, where its skin conditioning properties come in useful. Each of the two polymers are produced via different mechanisms, with polyethylene glycol being a chain growth polymer and dimethicone being a step growth polymer. Polyethylene glycol is formed by the ring opening polymerization of ethylene oxide. The initiator can be either water or ethylene glycol, and the catalyst can be either acidic or basic. The polymerization can be cationic or anionic depending on the catalyst. The anionic mechanism is preferred because the PEG formed has a lower polydispersity. This means there's a smaller variation in the polymer length and weight, which is favourable. The first step of the polymerization of dimethicone is the synthesis of chlorosilanes. This is followed by the hydrolysis of the chlorosilanes to produce disilonol, the monomer used for dimethicone. The final step is the condensation reactions between the disilonol monomers to form the polymer chain. Now, it may surprise you to find out that PEG12 dimethicone is in fact classed as a moderate hazard according to the Cosmetics database. It states PEGs should not be used on broken or irritated skin, with reports of kidney toxicity resulting from when severe burns were treated with PEG-based cream. However, the report did state that there was no evidence of systemic toxicity in studies with intact skin. This is thanks to the low molecular weight of the polymer, meaning it is minimally absorbed by the skin. So that's the two polymers I've been researching that you're potentially applying every day to your hair and skin without thinking. Thank you for watching.